Thanks everyone for joining the weekly N3C Collaborative Analytics meeting. This meeting is being recorded and the link to the PowerPoint is also pasted in the chat window. So we'll go ahead and get started. Justin, you want to take it?
Yeah, thanks, Usman. Here's a brief overview of our agenda today. I think of note, we want to talk about how the system we're designing can improve like transparency, reproducibility, and research, and start to think about some early work that that will describe the cohort that we're developing that we can publish on and provide a reference paper for this initiative, and also how we can start thinking about additional tasks and efforts that might link external groups and data modalities. So let's first give some updates on key stats. We've sent over 70 DTAs, 33 of which have been executed. We've had 13 who've had completed IRB protocols. And I think if you take the intersection of DTAs and IRB, we can get a count of 10 who've completed both of these hoops. We are now engaged with 18 groups for data acquisition. And as Emily Pfaff has pointed out before, you needn't have complete the DTA to engage with this group and start thinking about how you'll want to integrate with their work, with the phenotyping work and the ability to apply their scripts to start developing your cohort and preparing it for transfer. So if you haven't engaged with this group yet, very much encourage you to reach out and start that process. Okay, so here's our familiar diagram that depicts how we're structured. In N3C, we have our 5 work streams. This, of course, is collaborative analytics, which has 4 subgroups. The NLP, which launched last week, and I'm happy to say we now have a time that this group will be meeting weekly. This is Thursday at 3 p.m. Eastern time. So that will be displayed on the website. I hope if you're interested, you can sign up and register your interest as part of this subgroup. And you'll notice I've appended a new concept to workstream subgroups, and now we have a concept of task teams. Let me kind of briefly describe what we mean by task teams. There are a growing number of communities of interest that we want to be able to support, but maybe not with the same degree of support that we have with our work streams and subgroups. And so we have this concept of a task team. This is very, I think, lightweight and perhaps transient group that has the ability to meet and discuss issues that can be coordinated within N3C. Here's just some very preliminary ideas of different task teams. This is a lot of this has come out of the clinical scenarios group, and to the extent that we can socialize this, share this, and have ways in which people can become engaged, we would like to support. Of course, we don't have nearly enough program and project managers to support everything that we want to do, so we want to be able to incubate these task teams, but at the same time not necessarily be heavy-handed or have a lot of the same kind of program support that we might have for the other groups. So we will be developing this and sharing how one can be engaged with task teams, how you can form your own task team if you're so inclined, and how we can socialize this and share this with everyone across N3C. That will be this in development, and more information will be shared about that soon. Okay, switching gears to accessing training to the Palantir system. This is a slide I had last week. I had hoped that we would have been able to provision access for everyone who's part of the collaborative analytics last week. Unfortunately, we weren't able to complete that, but I am hopeful that early this week, if you join the collaborative analytics group, then you will automatically have a Palantir and N3C environment access provision for you. So if you've joined this group, then you should be expecting an email within the next day or two that will that will essentially welcome you to this system, give you instructions how to log in, and then have the ability to start self-training. There will be online tutorials. There are hosted weekly webinars that can provide information about how to use the system. So that will provide you access to the system. Now, of note, we still do not have the data use agreement finalized. So these don't exist, which means there's no access to the data itself. So this will be simply access to the environment where you can begin to plan and learn about this environment. Once we do have the DUA completed and your institutions sign off, and once we have the DAC system in place, then that process for gaining access to either safe harbor data or limited data set will be provided. So hopefully that answers. I know there's been some questions around this. Hopefully that clarifies it for many of you. Okay. Oops. I seem to have an error with my Google Drive. Okay, well, it looks like it's not going to let me go in presenter mode. So let's switch gears now and talk about reproducibility and transparency in research. I think at this point, many of you are aware of the issue with Surgisphere and the recent retractions in the New England Journal and the Lancet journals. I think it's fair to say that we at N3C aspire to be the opposite. In fact, I think we truly are the antithesis of Surgisphere in the sense that we intend to be an open environment. We aspire to promote full reproducibility and transparency of our work. And I think we should all be highly motivated by the lessons from the Surgisphere debacle. So I think it's really worth paying some attention to how we're designing N3C and how everyone will be able to work in this environment to promote reproducibility and transparency. And I think we've seen some examples already in the Palantir system of how our workflows are very explicit and how they can be defined with data lineage in place and provenance. So I think the tool set that supports this is very rich. But what perhaps we haven't heard as much about is how to be transparent in our research and how to make sure that what is in the N3C environment can be propagated outward, how we can make sure that our code and our methods and our publications can be as open as transparent as possible while still respecting the security of the data enclave itself. So I've asked the Palantir team to give us a little more insight to how we might use their environment to promote reproducibility, attribution, and transparency. So, so Nabil, if I can hand it over to you.
Yes, Andrew's actually going to take this one.
Oh, perfect. Okay, so I'm going to stop sharing, and Andrew, if you want to go ahead and present.
Great, happy to. Perfect. Can people see this?
Yes.
Okay, great. So please ask any questions or put them in the chat and someone can relay them to me. But I'm just going to go over a little bit of how Foundry automatically captures provenance as part of the security infrastructure and how this is intimately tied to reproducibility and understanding of where all data comes from. So we're looking at here the model that was presented to the NIH leadership meeting a couple weeks ago. And I'd like to dive a little bit more deeply into this feature importances data set here. So I'm going to open it up. And then I'd like to ask, just as I would with any other data set, what is everything that is required to build this? Where does it come from? So we'll push explore lineage, and we'll take every single node here, every single input to this data set. So I can see the data set of interest here at the end, feature importances. And then I can actually zoom out to understand the entire chain that led up to this. So some of these data sets here, each node here is a data set, and the lines between them represent transformations. Some of these, the nearer ones, actually were in the code workbook that we were just looking at. But many of them are actually involved in building the data set that we started with. And so we can go back and actually understand that. And these white boxes represent connections to external systems. So this is sort of the farthest back you can go, because this is where the data was brought in via SFTP from the NCAT server. So in this case, the data are processed. I won't show you some of these because the very upstream ones are LDS data before being converted to Safe Harbor. But here is one that we can look at and understand the code, as well as the result here of the data, in which each individual feature is converted into a minimum and a maximum and an average for each of the labs, and then the occurrence or not occurrence for each of the conditions. So essentially, it's not possible to have any hidden steps. I can't take this data out somewhere and modify it in some way and put it back in such a way that it's not clear how it came about. And this is a real advantage of operating in a central platform that is designed to track this lineage. So let me go back into the library here, into the code workbook here, and take a look at the concept of branching. So as you might expect, the logic, just like in any other source control system, is versioned and branchable. And I can go and look at any other branch of these. But what is actually unique about Foundry is that the data sets themselves are also branched along with the logic. So that means it's possible for me to keep track of what did this data look like on this day or in this branch, and actually compare it to other versions. So for example, if I want to compare the feature importances here for the branch where we were taking a look at acute kidney injury, to those where we were looking at ventilator usage, I can see what's actually different about the data. The columns are the same, but some of the feature weights, there's a higher maximum feature weight here in the other branch. And I can see that this one was using ventilator as the primary outcome of prediction, and this one's using acute renal failure. Furthermore, I can also go in and take a look at how each of these data sets was actually built. So you saw the logic before. I can look in great detail about any one of these times it was built, and I can see it's been built by different individuals, myself as well as Harish, and I can see exactly what the job spec is for each of these builds. And this job spec contains, in a transparent JSON format, all of the resources required to build it and information about the Python environment in this case, since it's a Python transformation that is used for actually running this. So that's the Python version and the packages that are involved. And then similarly, I can apply a series of health checks to this data that are specific to the version. So lastly, I just wanted to quickly point out that it's possible to extract these entire workbooks with just a simple git clone that is secure and uses a token with your login details. And you can also do that in the authoring environment, which we haven't used much yet in our trainings, but it's another place that you're able to write code and build transformations inside the platform. So happy to take questions about that. Joe, anything else?
So Andrew, this is Melissa. just one comment I wanted to make, and I'd love folks to help participate in kind of envisioning this, but because we're collecting ORCIDs, basically contributor identifiers for everyone who enters the system, your user profile can have your ORCID. And then, part of this full provenance chain also can, at the end, result in a report that would demonstrate all the different things that any given person had contributed to in a result. And so we have a contributor model that we had developed previously. That's a very simple model that just says, person X contributed in such a way to artifact Y. And we want to be able to include that attribution as an outcome in the final reports that are generated when someone is done with their analysis. And so if you're interested in attribution and how that should be sort of documented and disseminated, would be interested in hearing people's requirements.
Yeah, thanks. When I heard you say that before, Melissa, I added my ORCID ID to my
awesome
page here. And you can see some contributions that I've made recently. These just appear automatically. And then here are contributions that I've made to things that have been viewed a lot. And then you can, programmatically access this information as well as hitting it in various places in the UI to find out who contributed to each of these things and when. I should also point out you can look forward here and understand any analyses that are dependent on this. So if I look what's downstream of this, okay, this doesn't have anything interesting. But if there are contour analyses or other code workbook analyses that are built off of this, then you can see that as well.
Terrific.
Hi, this is Pete Solovich. I had a question in terms of reproducibility. One of the things we've run into is that a lot of machine learning algorithms include random number generators. And unless you set the random seed, you're of course not guaranteed of getting the same random number every time you run a model. And so you can have two different runs of the same model giving you different results. Have you thought about how to deal with that?
Yeah, so in our experience, we do typically set the random seed. And if you don't, we of course can't help it if your code does generate a random number, but we could make it possible for you to very easily look at two different runs and say, wow, the code is exactly the same, but the output is different, so that you could very quickly determine that there was a random number generator happening in your code, or that one of the upstream data sets had changed, and you can see that as well. So you could quickly determine that was the source of the variability, and then use that to set the seed. But we don't force anyone to set the seed currently, in part because you'd have to force it for every library that does that.
Andrew, could you comment on how to publish this externally to Foundry? If you want to publish a workflow or to an external GitHub repository, to what extent is that supported?
Yeah, so there are a couple of ways here. So you can just clone this out like this. We actually haven't added this to Unite yet, so you won't see it there. This is the NIH instance, but we can just turn this feature on Unite. And then it's possible to clone out all of the logic and push it to some other repository. Of course, the logic that you write will require a few changes to run if you're not going to run it on Spark, but that's relatively straightforward to change quickly.
Hey, Andrew, there are a couple of questions in the Q&A and chat as well. So one is the data quality group to examine data from different sites, potential quality issues. I think it's maybe a broader question.
I think this is a question for Chris. So this is really
Yes.
his purview. If Chris, you want to tackle the data quality question.
I'm sorry, can you repeat it?
is a data quality group to examine data from different sites, potential quality issues?
Yeah, the data quality and harmonization process will run the data quality dashboard for data submitted by all sites and return that data to each contributing site with a goal of, with each refresh, we'll have incremental improvements in data quality. We are going to make decisions about whether data is that fails certain criteria at a row level would simply be censored and not sent on. That's a possibility. It's something we'll have to discuss, presumably with this group. How again this gets at how paternalistic should data harmonization be with respect to changes and content. To my knowledge, we're not publishing the data quality metrics publicly. They'll be shared with the organizations. We will, of course, run the data quality dashboard and similar types of metrics against the final aggregated data set that we create. So known data problems will be published and available to the analytic community in terms of minor inconsistencies and incompleteness and similar types of content, but won't be attributed to any site. The spectrum of data quality checks that we are creating is, as you all know, drawn from the experience, communities, and practices of the 4 CDM communities contributing to the harmonization process. So it's a hybrid, more or less, that was optimized for what we thought was N3C use cases and data focus. For example, we're not having any of the data elements associated with clinical trials, the logistics and mechanics of clinical trials incorporated at this time, since the emphasis is on electronic health record data that can support secondary analytics.
Thanks, Chris. We have a question from Kelly Walters. Will users accessing row level data need to have an understanding of OMOP to use the data well? I guess it's a question of what we mean by well here. Obviously, given we're using the OMOP CDM, knowledge of OMOP is extremely useful. I think we expect and hope that there will be many derived data sets from the quote raw OMOP data that might be more analytical ready that others can use. But perhaps so one wants to go back to first principles, and the knowledge of OMOP data would be very extremely helpful. I don't know if anyone has a more nuanced answer than that.
Yeah, we already have an example of that. In fact, where there were in the rough cut of the data from the 3 sites that we received for the demo, there were substantially different term usage for the same semantic idea, and we, came up with some code sets to help bring together the different sites for concepts like blood pressure and creatinine, et cetera, and then created a simpler data set, with 1 row per patient and a set of features, and you can use that to build a variety of different models without understanding the OMOP data model. So I think the idea would be, I think it's possible to have these various derived data sets published in a data catalog. Here right now we only have training data sets. On the NCATS instance we have many more, and you could imagine publishing these here, and you could be confident that they were signed off by whatever experts we want to have sign off on them as valid starting points for an analysis.
And
I'll just add to that, I think broadly it is going to be very useful to understand, I wouldn't even think of it exclusively as the OMOP common data model, but the way in which all the terminologies from all the different CDMs have been harmonized to really do phenotyping properly. That's sort of a basic step for almost any of the analyses. And without understanding that, it will probably be challenging for N3C users to be using the same codes in the same ways to try and identify the same phenomena. So I think there's a almost unavoidable takes a little bit of learning to know how the phenomena that we're studying are represented in the data that we're using, and that whether that's coming through exclusively through OMOP or just in general, is understanding how those vocabularies work is part of doing that right, I think.
So Andrew, this is Melissa. I have a quick question about that. So, because we're obviously trying to support communities that might be, coming from different non-OMOPian communities, that might come in with, a terminological value set or entity from a different terminology. How, or tools that use those. Do we need to support equivalency determinations within the system separate from what is already in the Atlas tools?
Yeah, so it's the tooling that Atlas provides is on top of the vocabulary part of the OMOP CDM, right? So all of if you've got pCoreNet data, you're using a lot of the same terminologies, and you might be making similar kinds of choices about how to represent labs or lab values or conditions and so forth. And so that's what I meant by saying it isn't really so exclusive about Odyssey or where you're coming from. It's kind of how these data, how we're trying to understand drugs and what a whole class of drugs should look like and what the code set for identifying that whole class should typically contain is something that you need to do regardless of whether you're starting off with data in I2B2 or data in PCoreNet or any other form. And I think there is some helpful tooling for dealing with it when it's in OMOP form. And there's a lot of mappings that do that translation automatically, and that a lot of work has gone into the curation of those. But that's what I meant, is that I think there's some getting to grips with how the phenomena that we're studying are represented in healthcare data is somewhat complex, and regardless of which format you're using, there's some work that researchers have to do to use it properly. That's the gist of does that make sense, Melissa? Or is that confusing?
It does. I guess my question is maybe even goes one step further. It does. No, that makes perfect sense. But I guess one step further is, what if I have a terminology or value set that's not in the OMOP collection?
Yeah. I think, and Chris, you should jump in. You were brought up a question on a call the other day. It may be worth repeating here because I'm not sure we reached a resolution on it. But it was about I guess the paternalistic decisions that you guys, using your own words, that might be made to overwrite some local representations that could, your group might choose to do to help resolve some of the issues that Melissa's bringing up. That I guess has more to do with equivalencies, but things that don't have a standard representation yet in the OMOP vocabularies, I guess, is a large topic. And exactly how to handle those is a good thing to get clearer about. But I guess I've raised two questions to your one there.
I think that one of the things that's going to be helpful is, because we've got the various projects we're launching, both Cohort and the sub-area projects, I think that we're going to develop a lot of experience. And as long as we have a good mechanism for the various groups to communicate in the context of asking the various clinical questions, I think we'll be able to clarify this. The critical thing is obviously to make sure that the different groups don't clarify it in ways that are not consistent with each other.
Yeah, that gets at why the harmonization group was exploring preserving original codes in JSON text in the source files, and then adding the detailed LOINC codes. For example, the flavors of creatinine is the favorite poster child in the equivalent JSON expression, and replacing them with a common method-independent code for creatinine, which of course is present in the OMOP Atlas coding world, all the children and descendants, for example. But whether it is useful for naive investigators to have that sort of pre-populated in the data set. And then the question is, where is that done? Is that done as an extra table on the analytics side, or is that done in the harmonization process? I think there are advantages to both strategies, and you're quite correct, Andrew, that we did use the term paternalistic in suggesting that harmonization may overreach and trying to estimate what most users might want. But we're not precluding users from creating their own aggregations by retaining the original LOINC codes.
That's a good strong default with ability to leave the default if people deliberately choose to, seems like kind of a good balance.
Exactly.
Yeah, and I've seen this quite a bit in all of the different projects that I've worked on. And in the data catalog, we typically have several versions of data sets where people have made different paternalistic or less paternalistic decisions about how the data should be cleaned up, whether it's mechanism of action of drug or any other field that is open to some interpretation. So I strongly support the idea of keeping the original codes in there, as well as providing a sensible default and making them all available within the platform.
So Andrew, while you have the data catalog, to steer the conversation in a slightly different direction, there's a question about the search interface and how people can find specific data and workflows in the system. And obviously the data catalog can have maybe that's the more paternalistic approach where we can curate and have well described data sets there. But what are the other methods for more broad-based search, how you might annotate things or provide discovery within the platform that might not be through a central data catalog?
Yeah, so the data catalog can actually store data as well as transformations and applications and really any resource. But that said, I can also do a rich type of search here, where I can look for tags. And these are the tags that we've added right now. They're completely customizable. But I can search, for example, things with the measurement domain tag. And I find one example of that right here, where we tag the SynPuff data with it. But you could have a tag for each site. You could have a tag for, really whatever you want. It's up to a sort of central committee to make decisions like that. And then, so that's a common way of finding both applications, data, and interfaces. And then within the code workbook application, you can also add templates. Well, I'm on a protected branch here. But you can search for new templates also based on tags or their text that are available within the system. So we actually don't have many on this instance. We do on the NCATS example.
All right, thanks.
And then I would also add one more thing, which is that you can configure the templates to work on data sets of specific tags. So for example, you could make a template that only works on OMOP measurement domains that are safe harbor. And it would be a suggested template for those data sets.
Great, thanks. We have some additional questions, but I perhaps we can come back to these if we have time at the end. Like to move on with the agenda here. Okay, so. Okay. So just want to move to our next topic, which is thinking about preparing for once we have access to data and people are wanting to start their independent research areas and ability to publish, of course. There's been some very nascent work in thinking about how do we provide some of those reference articles that others can use downstream. And so there's been conceived of two manuscripts that we would like to start developing. One is more of a methods paper that would really describe the overall N3C initiative, how it's structured, and how we're basically organizing, generating this resource for individuals. and that's still quite nascent, and we're thinking about how that would be structured, and we'll provide more information to everyone to be involved as we flesh that out. The second area is thinking about, okay, now once we have these cohorts in our system, how do we characterize them in a very general way? It's I think these cohort characterizations are happening at many different sites and healthcare providers, and we're starting to see more and more of these. And I think there's a somewhat of a pattern to to how they're crafted and the kinds of questions they answer. And so I think we would want to do similar, but obviously in a more aggregated and integrative way. So so it's probably not too early to start thinking about what those analyses will look like and how a paper like this might be structured. And so to that end, Joel Saltz will give us a taste of what his institution has done at Stony Brook, and hopefully seed some thoughts about how we would do this for the N3C cohort itself. So Joel, if you want to take it away.
Okay, thanks. So I'm going to share my screen, and this is really, so what I'm going to do is present sort of an overview. Can people see my screen? Is that visible?
White.
Okay, let me go into projection mode. So let me contextualize this a little bit, because so I've been involved with
still just a white screen, Joel.
Oh,
you must have your no PHI filter on.
No, I don't. Let's see. So I'm.
Oh, you're sharing the where you can the interactive screen where you can doodle on it.
You're showing a whiteboard, I think, instead of your screen, maybe.
Okay, I'll try it again. Let's see. Share screen. Oh yeah. This thing has been the curse of my, well, not really the curse of my existence. That's a little strong, but it's confused me a couple of times. Let's put it that way. Okay. So can you see that now?
Yep.
Yes.
Okay. So there've been a variety of discussions about these sort of initial documentation of what the community has been working on, as Justin was talking about. And what I think has evolved is that there would be a description of the methodology, how data is aggregated, managed, curated, mapped, Palantir, auditing, and all of that. And then we would provide a description of our cohort. And so a number of people, and this is really an open group, have been meeting initially informally and now somewhat more formally to brainstorm as to what the initial analysis would be. And I think there's agreement that this initial analysis is not supposed to be any kind of ingenious deep dive into any particular clinical question, but really a description of the cohort, the N3C cohort. So a number of places have generated papers describing these cohort descriptions, and we're one of them. And Sandeep Malapadu, who couldn't make this call but is involved in the N3C in a number of contexts, including this one, as well as the AKI group, was the clinical lead, and Richard Moffat, who's on the call, was the person who actually did most of the work, along with Janos Hajapos and Tassin Kirk. So I'm just going to quickly go over the tables in our still pending manuscript, which I think is notable by its deliberate lack of creativity, in that it's really a descriptive paper. And it's probably not a bad template for what we might want to do, but the notion obviously is to bring in everybody's ideas. Okay, so it starts out with gender, race, ethnicity, insurance, some of the things that were on the initial dashboard. I just cut and paste the figures to this paper. Current smoking status, the various comorbidities associated with the disease, body mass index. So it's really, in our particular case, we had 1,325 admitted COVID positive patients. There's another roughly 2,200, 2,500 total positive patients, some of whom were not admitted. So the straightforward stuff. So then a bunch of mind-bogglingly boring sort of descriptive statistical information, but important, obviously. O2 sat, respiratory rate, heart rate, temperature, systolic blood pressure, mean arterial pressure, with various breakdowns that we felt were clinically meaningful, laboratory values on presentation, relevant laboratory values, EGFR, kidney function, pH, liver function, lactate, ferritin, D-dimers, and some of these things, such as D-dimers, which have great specific clinical significance involving hypercoagulability, renal function. Then we chose breakdowns by particular value thresholds, which might or might not be what the group here would choose. Anemia, creatinine kinase. So basically a bunch of lab data that pertain to the comorbidities that are seen, comorbidities and morbidities, organ system dysfunctions that are seen in COVID-19 patients. And then break down by patient mortality, gender and age intervals. So this is, really descriptive stuff. Obviously, it's not every possible piece of information. We cherry pick as what this group is, as did the papers that we frankly based our analysis on, or at least some of our analysis on, relevant organ system, failures and issues that come up with in COVID-19. And discharged, deceased, discharged, alive, with median and IQR, certain amount of analysis based on invasive ventilation, which a couple of the nuances that the group will have to deal with. One was actually nailing down what was invasive mechanical ventilation. There was some discussion of that even in our initial demo from WashU, because that's not something that all sites, including ours, actually explicitly captured. We had ventilator settings for a while, and then for CPAP and BiPAP, we had to sort of go back and say, okay, what really, who was really intubated, and then we got a discrete data element on that, and I think that that's a case that is not uncommon. There was also anticoagulation that was either essentially prophylactic or used in treatment, and we had to sort of go through the mappings and through our XNORM and look and essentially work with our clinicians to nail that down. So there's some nuances that we've discussed actually in some of these other earlier calls. Discharge disposition, and then Richard Moffat, who's on the call, did some sort of basic statistical analyses. Actually, why don't I let you, Richard, narrate these things, because this is your analysis, the odds ratios and the like.
Yeah, so for this part, we just did basic logistic regression, trying to predict survival or death. And this table is just the univariate associations, the odds ratios. And then what we did was we took the stuff that was significant from the single variable analysis, and then we threw it into a multivariate predictor. Again, just using logistic regression, but we used lasso, so it was regularized. Ended up picking just a few features, and with just those few features, either predicting outcomes from initial labs and comorbidities, or from a couple, like AKI in hospital was the #1 indicator of overall death for ventilated patients, which I think, yeah, you're showing there, or history of heart failure. So these pretty parsimonious models with just like 4 or 5 features were actually doing pretty good in predicting outcomes. The original goal of this was to resolve the question of what is our overall mortality. And since we still had a sizable number of patients in the active in the hospital, we wanted to throw together a model that might tell us how the patients who are currently in the hospital would eventually turn out. And so the goal wasn't necessarily to identify, you know, what is the end all for important features for predicting outcome, as much as come up with a classifier that would be robust and not overfit too much, given our modest sample size.
And then we did a set of analyses both for mortality. Let's see, so it was overall mortality and mortality for patients who were on
had been ventilated, yeah.
And then looked at comorbidities as well as treatments. And so, and we of course got this accepted into Lancet and the New England Journal with made up data, and then with, no, just kidding. But obviously, since none of this is statistically controlled, but because we do have quite a number of sites, it will be very interesting, although no doubt, you know, not necessarily decisive, to actually look at the relative efficacy of different treatments that have been tried at different sites. Obviously, there's a lot of correlation, but so we went through that as well. So any other? What have I missed, Richard?
Just like we started to answer a lot of the low-hanging fruit questions, but we ended up backing off eventually, especially on the medications, because we couldn't really separate administering the med with the outcome of the med. For example, hydroxychloroquine, like getting it in the hospital was like a death sentence because it was only given to the patients that ended up getting intubated, right? Meanwhile, getting hydroxychloroquine given by the pharmacy was perfect. Like no one died. It's because they were getting it from the pharmacy on their way out the door. So there were lots of like obvious questions and tricky answers that we just didn't want to include in the paper because they were just, you know, it wasn't a randomized controlled trial.
And the therapeutic anticoagulants were interesting. Our you know, because our population was pretty small and because it's not a controlled study, I think it's probably fair to say that it's hard to make really definitive conclusions, although some of the numbers are fairly large. But I think that will be that may be actually interesting with the larger population.
Yep.
Anyway, so that's you know, so I think that what we will be able to do is to really come up with a very solid description of the disease. One of the ways I've described it is in a year or 2 or 3, whenever the next version of Harrison's medicine comes out, you know, the description of, you know, okay, really what are the you know, what are the risk factors of it becoming very, you know, very you know, multiple various system involvements and the disease becoming you know, progressing to the point where people are mechanical ventilation or die or have renal failure or hypercoagulability, along with you know, what actually happens with the disease. That this sort of study, I think, could be a very landmark documentary study, just describing what happens. It doesn't obviously tell you that much, or like necessarily anything at all about mechanism. So okay, so that's I think what I have to say there. Any questions or thoughts?
And I think it's worth noting again, Joel, you already pointed out that this very exercise, I think, will be, you know, others downstream or come later will be able to leverage this in their own more focused analyses. So hopefully this is you know, it's setting a very stable foundation for a lot of other things to come.
And I think in terms of some of these data, essentially defining data elements, when we, you know, essentially define what we mean by particular laboratory test values or therapeutic levels of treatment or whatever it is. Obviously, I mean, I like the idea, Chris's idea of setting defaults so that people who don't want to reinvent things can choose a default that's been used other places. So when the deeper dive analyses or various PI studies look at particular issues, or when groups use hashing to integrate additional data sources, you've got sort of a backbone of context that people in variable definitions, data element definitions, people can work on. I mean, I do think that in terms of the methods paper, this really could be a really good prototype for other types of disease studies as well.
And in addition to a published manuscript, you know, this is very much envisioned to be a living dashboard and table within the system itself. So as new data comes online, these dashboards get updated. We can see these new descriptive statistics. So this will be, you know, an ever ongoing update to our descriptive statistics.
Right, and I think we've got a really good start because we have I know we've got the COVID Odyssey work that Andrew is doing, and then Richard's code, our code can be, you know, will be integrated into the system or just deployed, and that's something that, you know, either he or we will do, or the Palantir folks will do, or some combination. So I don't think it'll take a lot of time, and I know Tel has similar analyses, and I think I don't know whether his code is Python or R, but one way or the other, you know, so we really have a head start in you know, getting this stuff generated. Obviously, there's a lot of QC to make sure that all the moving parts are making sense, but I think we can move pretty quickly.
And again, this is collaborative, right? So we if you're interested and want to participate, we will provide on-ramps to get engaged in these various efforts. Joel, we only have 5 minutes left. Did you want to touch on the image hashing question, or do you want to say?
No, sure. No, I'll talk a little bit about that. My sub area is really not image hashing, but I'll give my perspective and then maybe talk about imaging. So the notion of integrating external data sources, whether it's imaging or molecular or pathology, is obviously not obviously, but it's an extremely fruitful potential area, because this having a sort of a sort of central phenotype, clinical phenotype characterization mechanism that can be used to inform studies that might, for instance, give information about imaging biomarkers that will tell, you know, that will give indication as to whether or in what way the disease will progress, or for that matter, whether the disease exists in the first place in cases where you might have inaccuracy in the laboratory testing. So that's a big area, and there's been a hashing group that's been meeting, working out a lot of the regulatory and technical details. And my involvement in this, along with Fred Pryor, and again, it's an open group, and people who are interested in engaging this, essentially integrating image analytics to this effort, so that basically there are a bunch of people in the imaging space who are interested in looking. Initially it was pulmonary CT and chest x-ray, but now given the multi-organ site involvement analysis of, you know, frankly, most types of images, and then asking either questions about progression of the disease, possibly response to treatment, possibly whether or not the disease exists, or about multi-system, you know, involvements. neuroimaging in terms of brain involvement and the like. So this is a subgroup that Fred Pryor and I, and really anybody who's interested, is launching. We've agreed to present at least our organizational plans a week from now, but really at this point, I think the agreement was that this is an important thing. I should also say that the imaging effort gets a big boost because independently, the Cancer Imaging Archive is aggregating images from a bunch of places, including Stony Brook, but the NCI is arranging a bunch of images. So Fred Pryor, I think, will be able to get 20,000 patients' images for patients. So then those will be de-identified along with some pretty modest clinical correlation. But then the notion of relinking those to the limited data set, and as I understand, potentially Reagan Stripe will act as honest broker through this process. So then it would be possible to ask, nuanced questions. So this is both important in terms of imaging, but also really useful as a prototype for this process of using the N3C sort of core to provide deep and rich clinical phenotype information, progression information for people with other types of data. Okay, so we've got 1 minute, and I think I always hate meetings to go over, so I'm not going to make that happen. So I think I'm done. Thanks.
Thanks, Joel. I think we're out of time for questions, so keep your eyeballs peeled for the invite to the Unite environment. If you don't already have it, we expect that to come out the next day or two. So thank you, everyone.
Okay, thanks.
Thank you.
Everyone, thank you.
Thank you. Bye.
Thanks.